Okay, good day, everybody. We are starting a new chapter, chapter 6, and now heading towards a final exam for the course. This unit will be due on Friday, November 1st. So that's a full week from now. All right. That is because on Monday, the 28th, we are taking our test, our midterm two, and on Wednesday, the 30th, that is the day of Shalom, so a day of rest. And so you guys should use that as a great time of reflection and just focusing on how you can finish school and move forward. All right. So this is quite a bit ahead of time. It's not due till November 1st, and we'll take on the second part of chapter 6 on that Friday. All right. So let's get started and get going here. One of the things I want to talk to you about that I think is really important is that as we've gone through, I have tried to show you how the arithmetic that we do in elementary school is really the same thing that we're doing with polynomials. And so now I want you to kind of remember back to elementary school. First through fourth grade, we're learning how to add, subtract, multiply, and divide with numbers. And then along about fifth, sixth grade, we come up to a topic called prime numbers and prime factorization, where we break numbers apart. And it turns out this prime factorization becomes very helpful in algebra. But prime factorization is where you take a number like 40 and then you break it apart. Now, I remember doing this with tree diagrams like 8 times 5. And then I'd break apart the 8 like 4 times 2 and the 4 to 2 times 2. And so you could say 40 was 2 times 2 times 2 times 5. And every number, if they're not prime, has a unique prime factorization. In fact, that is called the fundamental theorem of arithmetic. And so this is a big deal, breaking numbers apart into their components. And we use this to help us with fractions and all kinds of things. Canceling in fractions, multiplication, division, all kinds of things. Anyway, since polynomials are just these kinds of numbers in disguise, we want to be able to do a factorization of polynomials, break them down into their component parts. Okay? And so that's what we're going to do, and this is in preparation for essentially what we call rational expressions, which are polynomials made into fractions. And so that's what we're heading towards. So we have to learn how to factor polynomials. All right, let's get going. Okay, I have 4 problems here that we can look at. First of all, a greatest common factor. We're going to look at what we call factoring the greatest common factor. And when we do that, we're looking for something that's in common with all the terms in a polynomial. Okay, something that's in common. Now, essentially what we're doing is we're doing the distributive property backwards. You'll remember the distributive property says if you have A times B plus C, then that is equal to A multiplied by B plus then a multiplied by c. Well, if you go backwards, you're looking for what's in common between these terms. And so you factor it out and you write your answer in the factored form, what it looked like before you multiplied. Now, this first problem's pretty easy. What we can see is that this is 8 times x plus 8 times 1. All right? So both of them have an 8 in it. And so we can factor the 8. In other words, pull that 8 out, factor it, and we are left with x plus 1. All right? How do you check your problem? You check it by just re-multiplying it and see if you got with what you started. So 8 times x plus 8 times 1 is 8x plus 8. So I am confident that I have pulled out a common factor. Okay? And then a greatest common factor is going to occur when there's nothing in common between the terms. And so x and 1, the only thing they have in common is 1. So we have the greatest common factor. Okay? So let's look at the next problem, the 30x minus 12. So there are no variables in common between each of these, okay? No variables in common, okay? But when we look at the numbers 30 and 12, what's in common between those two numbers? Well, what we could do is we could use prime factorization to help us. And 12 is 3 times 4. 4 is 2 times 2. And now what I notice, the greatest common factor are those things that are in common between both of them. So the 30 and the 12 both have a 2 in common, but they also both have a 3 in common. So numerically speaking, this is like my scratch work here. What's the largest number they have in common? Well, it's 2 times 3. It's 6. And then we know what's left over, the 5 and the 2. So when we go to write this problem, the greatest common factor is 6. And then we have 5x left over there, and we have a 2 left over there. And we can see that right there. Okay? And so 30x minus 12, this is completely factored. It has the largest, greatest common factor, and there's nothing in common between the terms on the inside of the parentheses, except for 1, okay? So let's go to the next problem, all right? So the next problem is 9y to the 4th plus 27y to the 6th. So when I look at this, I do the 9 first, and that's 3 times 3. And the 27 is 3 times 3 times 3. So I have a 3 in common, and I have another 3 in common. So that's 3 times 3, or 9, all right? So I now know that part of my greatest common factor is 9. Then I have to look at the y to the 4th and the y to the 6th. Well, y to the 4th is y times y times y times y. And y to the 6th is y times y times y times y times y times y. And so what's in common is y to the 4th. And so I put y to the 4th here. And then what goes in the parentheses? Well, what do you multiply 9y to the 4th by to get 9y to the 4th? Over here. To get this one, what do you multiply this one by to get this one? Yeah, so 1, right? And so that's 1, and then plus, and then we look at the 27. What do you multiply 9 by to get 27? Well, the extra 3. What do you multiply y to the 4th by to get y to the 6th? Well, the extra y squared. And so this will be 3y squared. And so we can check it. Is 9y times 1 9y to the fourth? And is 9y to the fourth times 3y squared, is that 27y to the sixth? If so, then this is a complete factorization. And notice the 1 and the 3y squared have nothing in common. Okay? So I've checked it, and now I'm certain that that's correct. So let's go to our last problem. All right. Now, if you get good at this, you don't have to break the numbers down. For instance, 100 is 10 times 10, and that's 2 times 5 and 2 times 5. 50 is 5 times 10, and 10 is 2 times 5, and 25 is 5 times 5. So what's in common between all of these? Well, it's the 5 times 5. So 25 is part of the greatest common factor. So we put 25. And then now we look at the y's. So I have y times y times y. I have y times y, and I have y. So what's in common? Well, just the y, that's the only thing in common. So that's our greatest common factor. So 25 and y is what's in common. And then what's left over? Well, we're going to have, let me put a little more room here. We have what's in common, and then what's left over is down here we have a 2, and a y squared, so that's going to be 4y squared. And if you multiply these two, you get 100y cubed. And then what do we have left over on the 50? We have a 2 and a y left over, so that's plus 2y. And 2y times 25y is 50y squared. And then do we have anything left over on the 25? And the answer is no. So we put minus 1. So a negative 1 times 25y is negative 25y. So this would be a complete factorization. Okay? So that's how you do it. All right? And ready, let's try this. So here's one for you to practice. Give it a shot on your own and see what you come up with. Okay, we're back. Let's do this. So what I'm doing is I'm looking what's in common. And so I look at the negative 4 and the 6, and I realize 4 is 2 times 2. And so let's put my scratch paper over here, 4 and 6. So 4 is 2 times 2, and 6 is 2 times 3. So what's in common? It's the 2. All right? And then what's left over? Well, we have a negative 2 here because we got to pay attention to the negative sign. So that's this right here. And then we have a 3, so that'll be plus 3. So there's our number portions. Now we look at the variable portions. So I have a cubed and I have a. So what's in common? Just the a, because this will be a squared times a. So only the a is in common. All right. So that's part of our greatest common factor. So we put a there. And then what do we have left? Well, we have an a squared left here. But since we use the a, we just have a 1. 3 times 1 or just 3. So we've already used up the a. And now we look at the b squared and the b. And again, b squared is b times b. So we have a b in common. All right. The b's in common. Just like we had the a's in common. So that's part of our common factor. And when we come back, we have a b left over. So we got a b for that one. But we've used the b in the 6ab. So this would be a complete factorization. 2ab times negative 2a squared b plus 3. Now, I just want to show you something. You could have also done this as a negative 2ab and wrote this as positive 2a squared b and then put minus 3. And this would also be correct. All right? It's just an alternate form. And basically, you factored a negative 1 out as well. Okay? And that's something you can do if you wish. You don't have to, but you can. All right? So there you go. You got to practice on these. This is really doing what I like to call multiplication backwards. So you got to be able to find factors, and you got to be able to do prime factorization of numbers, and that'll help you. And then with exponents, you always choose the one with the smaller exponent. All right. Next, let's go to the next thing. So what happens next is we want to take this greatest common factor idea and we want to expand on it in polynomials to grouping. And what do I mean by that? Well, it turns out sometimes you're going to get polynomials that get written like this, where it's not multiplied out. And so it's partially factored here. Notice we have an x. We haven't done a distributive law yet. They factored some things out. But what we have happened is we notice that we have a common group. So what this is like saying x times a minus 4 times a. And so we would say the a is in common, and we would factor that out and put a times x minus 4. Well, in this case, our a is the group x plus 2. So we factor the x plus 2 out as our greatest common factor, and then we're left with the x minus 4. And so this is completely factored. You'll notice it's a binomial times a binomial. And in fact, if we were doing the distributive property where we were multiplying, we would say it's x times x minus 4 plus 2 times x minus 4, which is another way to say x minus 4 is a group, and you still end up back here. And then we would continue the distributive property, which is just FOIL. All right, so we've continued the FOIL. And that's how we end up when we multiply. We use the distributive property to multiply, but when we're factoring, we use the distributive property to undo the multiplication. Okay? Undo the multiplication. All right, let's do another one. Okay, so here's this problem here, and we can see right away that the common group is the x plus y. We can see that right away, okay? Now, what we have in front of this one is a 7x, and what we have in front of this one is a negative 1, okay? So when we factor out the common group, x plus y, we are left with 7x minus 1. And so you have to remember these negative ones or positive ones, that when you factor a group, sometimes you'll just have a 1 there. Okay? And that's it. That's how you factor. Okay? So now let's take this one more step back and do grouping. Okay, here's two problems. Now, you'll notice that each of these has 4 terms. When you see a polynomial with 4 terms, it's always a good idea to check and see if you can do a grouping greatest common factor. And here's what I mean by that. What I do is I get it in sort of descending order of the exponents, 3, 2, 1, 0, x to the 1, x to the 0. So I get it in kind of that descending order. And then what I do is I look at it in two parts. And I ask, what's the greatest common factor of x cubed minus 2x squared? Well, it's x squared. I have an x squared that goes into both of these. X squared times x is x cubed, and x squared times negative 2 is negative 2x squared. So now you notice I've pulled out the common factor. I do the same for the 5x minus 10. Common factor is 5, and it's multiplied times x minus 2. Now, here's the key. What you notice is that now you have a common group, of course separated by the addition here. All right. Well, now you can factor that common group out. And so we write x minus 2, and what's that going to be multiplied by? It's going to be multiplied by the x squared plus 5. And that's how you factor by grouping. Okay? Key thing, you're seeing 4 terms. Second key thing is you're trying to make a common group. All right, so let's try this next one. Again, we have a 3x cubed minus a 2x squared minus 6x plus 4. We get the exponents in descending order. And then we look for what's common in small portions of them. And what we see is x squared is in common here. So we get a 3x minus 2 there. Now, the next one, we want to have we want the group to match. And we want a positive 3x in here. That means I'm going to need to factor a negative 2, because negative 2 times 3x is negative 6x. And negative 2 times negative 2 is positive 4. So there's my common group, the 3x minus 2. So now I factor out that common group, 3x minus 2, and I write what's left, x squared minus 2. And this is a complete factorization of that. Okay? So that's sort of the problem types and the way you do them. You could have 6 terms and have common groups of 3 terms. You can have lots and lots of common groups, or you could have 6 terms and have 3 different groupings of common terms. It's just something you have to look for, and you have to look for the patterns of common terms. All right. I like problem 93, just one of the harder ones, and let me show it to you. Now, when I look at this one, it is one of the harder ones because it has 6 terms. But what I notice right away is if I look at these in groups of 2, I'm noticing that they have the same coefficients in each group. A 3, a negative 3, a 1, a negative 1, a 5, a negative 5. That tells me there might be a common group. So I factor a 3x to the 4th here, and I get x minus 1. So do that multiplication, you'll end up with that. And then here I factor out an x squared, and I get an x minus 1. Oh, now I'm seeing the common group, right? And then here in the last two, I factor out the 5, and I get a common group. Okay? So there you go. Now I factor the common group, x minus 1, and then I write what's left over after the factoring, 3x to the 4th plus x squared plus 5. And that would be a complete factoring at this point. So you can have grouping factoring all the time, and it's something you want to be aware of. Now, we're going to use this factoring down the road to help us. And all we're trying to do with factoring is break it up into the things that were multiplied together that gave us the polynomial. So it takes some practice. You have to notice things. You have to be nimble with your multiplication facts and numbers. And you've noticed I've used prime factorization of numbers to help me find the right number. In terms of groups, I might look for similar sorts of patterns. Okay, so all of these things are things that become a part of factoring. So it's a multifaceted thing, and we'll look at it quite a bit in this chapter. Alrighty, that's all I have for you. See you later.